get somewhere in your notes. If you don't want to write this down, listen carefully and try not to forget. That's a lazy way, a silly way, a foolish way. If I were you, you're not going to have time to go find it and highlight it in your notes. You're not even going to have time to go find it and highlight it on your practice test, although I might be giving you some hints about certain things to highlight on your practice test. But things that you will see on the test. First of all, the test tomorrow is like a normal full-size test for the most part. Remember, we split it up into 2 days because it was always going to be split into 2 days. It's kind of a long test anyway. So some of you might finish it a little bit early, but please be careful when you're taking the test. My advice is still to come in early at 12:45, starting the test at 12:50 to have extra time. Multiple choice and long answer. Multiple choice and long answer. Multiple choice, you will not be allowed to use a calculator. And you will have to fully finish the multiple choice before I allow you to get out your calculator and get the rest of the test. On multiple choice, you will want to think about definite integrals expressing area of a region. That comes from section 4.2. Sometimes solving for that area using geometry, sometimes solving for that area using fundamental theorem of calculus, aka anti-deriving, plugging in B minus plugging in A, and sometimes just expressing that area as an integral. I think all of those things you guys saw in section 4.2, 4.3. Fundamental theorem of calculus part 2. What's fundamental theorem of calculus part 2? Ooh, it's on the forever quiz. Taking the derivative of an integral, whether it is, technically, yeah, you're right, Joe. Derivative of an antiderivative, but technically, I would remove it one step before that, a derivative of a definite integral. Know what to do if you're seeing an a to a u or an a to an x or a u to a u, negative u to a u. What if you're anti-deriving and you have multiplication or division? What should you think? Rewrite, because is there a multiplication or division rule for integration? No. So you have to somehow rewrite it, FOIL it, distribute it first, divide it, like split up your division among everyone first. What else should we rewrite when integrating? Square roots, anything with radicals, make them fractional powers. What about x powers in the denominator? You can make them negative powers, right, and use power rule. Ooh, what about trig expressions that are complicated? Maybe rewrite them before, because the trig rules, there are very certain ones we can go back from, and if that's not it, rewrite first. Anyways, all that to say, rewrite. What if you solve for the antiderivative and then you have to do some sort of making it match or plugging in? What should you do? Do you love yourself? Yeah. Rewrite it again, right? If you see x to the 1/2, make it a square root of x before you plug in, etc., etc., etc. Handling absolute values and integrals. Maybe a multiple choice, maybe a long answer, maybe both. Handling absolute value and integrals. What's the first thing we need to do? Find the zeros, split up the bounds with the x-intercepts. Good. What do we do after we split up the bounds and we have multiple integrals? Take the sum of all the absolute values, add them after you've found them, and then made any negative answers positive. Yada, 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 yada. Okay, long answer. You're allowed to use your calculator. Long answer. You're allowed to use your calculator. You are going to have a long answer where you have to do, listen, a left, right, midpoint, or trapezoid approximation using a table where the information is given to you in a table. You're going to have a long answer where you have to do a left, right, midpoint, or trapezoidal approximation from info in a table. No, the info's in the table. Oh, I said or, aka the direction is going to tell you which one is going to be one of those four. AKA study them all. But good question. Thank you, Joe. Thank you. I'm going to tell you which one it's going to be one of those four. You're going to have to solve some definite integrals giving clues, not functions, aka using function properties. Remember the whole A to A, B to A to C, B to C? No, A to C, C to B. I think that was section 4344, somewhere in there, the properties. You're going to have to solve using MVT. Now wait, if you're solving MVT, what are you actually solving for? C. And C is inside, or should be inside, the function f of x, right? I think some of our questions today might revolve around MVT. You're going to have to solve what I call the initial value problem, aka solve for the antiderivative given a clue. You're going to have to solve an initial value problem, aka solve for the antiderivative given a clue. Wait, if you're given a clue, what does that mean? You can solve or find the plus C. Good. You can solve or you can find the plus C. Let's go ahead and go through. I'm not saying that's all, but at least that's a pretty good chunk of what you're going to see tomorrow. Let's figure out what questions you guys have on the review and or practice test. Review first. That's what was due today. Review first. That's what's in CalcChat. Review first. That's what's required. And then if we have time, practice test questions you guys might have. Speaking of the practice test, really quickly, some of you might be like, ugh, she gypped us. Well, hold on. First of all, aren't there circled problems? Yeah. Only do those. Second of all, if you are just doing the circled problems, did anybody realize there are some kind of involved ones here on the backside? If you go to look at the answer key, because I'm awesome like that, and I wrote an answer key, and it's my work. It's me, myself, and I. Look at my handwriting. Ooh, that was... Anyway, coming back. Ah, I didn't do these? Oh, yeah, I did. Anyway, you might want to go highlight number 21. Not so sure we'll get to it today, but what does 21 say? Find a left or a right or a midpoint or a trapezoidal approximation given a table. What does that sound a lot like I just said? A long answer, tomorrow. If I were you, I'd highlight that problem. Let's see if we can find any other ones to highlight in your guys' questions. What do you have for me? Test review, what do we got? 11, what else? 28, what else? 33, what else? That's it? 47, what else? 49? Is that what you said, Abby? I just didn't hear you. Yeah. No, you're good, you're good, you're good. I just couldn't hear you. What else? Let me see. I think I chose to do 21 over 16. 5 subintervals as shown in... Yeah, I think I chose 21 over 16. 16 is okay, but I wouldn't want you to do A, B, and C, so 21 was easier. Not to say that 16 is awful practice, but no, John, you don't have to do 16. Thank you for asking. Anything else from the test review? All right, I'm going to bust out the test review. If you guys are just bored and chilling, be working on the practice test, be working on writing out for your forevers, be working on studying your notes. Almost everyone has at least something they can be working on for calc tomorrow. All right, number 11 is a great problem for the test. So therefore, let's move to number 28. Number 28, said use geometry. Once again, number 11 is a great question for the part of the test you already took. So we're going to go ahead and put that in parentheses and see if we have time. Otherwise, we'll keep going because tomorrow would not have a question like 28. Oh, sorry, like number 11. 28 says use geometry to evaluate the integral. Did you guys forget already? What is the graph of the square root of r squared minus x squared? Semicircle with a radius of r. So when they give you 36 instead of r squared, what's your radius? 6. Good. It's not negative r, it's negative 6. It's not r, it's 6, and it's not r, it's 6. When they ask you for the area or the integral from negative 6 to 6, it's the same thing as 1/2 pi r squared. Why? Half of a circle's area would be 1/2 pi r squared. So this integral, 1/2 pi 36. Should end up being 18 pi, yeah? Nice. Number 33. Gives us the Definite integral from 2 to 3. Number 33, right? 2 over 1 plus x squared. You do not have to think about the picture. You do not have to think about the graph. You do not even have to think about the antiderivative, which you would not know necessarily right now because they say approximate this definite integral with the trapezoidal rule or the trapezoidal approximation with n equals 4. So I'm going from 2 to 3 using our number line. 4. Aren't I going by 0.25s, guys? Trapezoidal rule. What's the area of a trapezoid? Don't I find bases using delta x's? And don't I find heights by using f of x's? You guys agree? So then I need to go ahead and set up, if I was the long way, I'm going to have 4 rectangles. You don't have to show me A1, A2, A3, A4 tomorrow, or however many there are. You technically only need to show me the long drawn-out version, but somehow I need you to show me. Since they're all trapezoids, they're all going to get 1/2 because that's the formula. Now, for the bases, if you were to see this in a table, the information would be given to you as such: 2, 2.25, 2.5. Now, what happens to be true in this one because they told us equal subintervals? Since we equally spaced it out, what's going to be the base for every single one? 0.25, 0.25, 0.25, 0.25, right? Isn't it 1/4 or 0.25? So I'm going to do 1/4 just because it will be a little bit easier with the fractions. But guys, if the table wasn't equally spaced, couldn't these have all been different? The jumps? So whatever the bases are, need to plug in those bases, but these ones all happen to be the same. Now how do I get my heights? Plug what value into the equation? Though for trapezoids, I need to use both the guy on the left and the guy on the right, right? So I could plug in 2 pretty quickly, and that's going to be 2/5. But as soon as I get to 2.25, it's going to start to get nasty. So instead, I'm going to go ahead and just throw it in and then plug it into my calculator, since tomorrow you're allowed to use your calculator. And I would have to do that for every single trapezoid unless I did some sort of shortcut rule along the way. I want you guys in your groups, at least one person, to have a calculator and make sure everyone in their group knows how to find the Y1 var. Knows how to use and find Y1 of, like we did in our notes and like we did in homework, which made plugging in a lot easier for some problems when they were equally spaced. Do you remember how to use the Y1 var of, F of notation? I can pull out a 1/2. I can pull out a 1/4. Everyone in their group, a calculator has been gotten out, a Y var button has been pushed, and everyone knew how to get there and how to use it? Meanwhile, as I'm putting this all together, I pulled out a 1/2 because it was in every area. I pulled out a 1/4 because it was in every area. It's not always true. It is in this one. I could make this a little bit simpler by doing f of 2 plus 2 f of 2.5s plus 2 f of 2.5s plus 2 f of 2.75s. However, there's only going to be 1 f of 3. And you could plug and chug this to your calculator. Now, quick warning, this is not a final answer. This is how you get the final answer, but it's not the final answer itself. You'd have to go ahead and plug and chug your function 2 over 1 plus x squared as your y1. What would change if this was a left or a right or a midpoint? It wouldn't be a trapezoid anymore. What would be your area formula then? Base times height, so all the halves would be gone. You'd have bases, but you'd only have one height and not the other, and you'd have to choose for each jump. Instead of and 2.25 plugging into f, if you were coming from the left, the first one, and only use 2.25, 5 for the second one, only use 2.5 for the third one, only use 2.75 for the fourth one. What changes? From the right, which one would you use? F of 2 or F of 2.25? Yeah, you would use the latter ones only. Remember I told you guys practice test number 21, the solutions shown in the answer key. Might be good to study for left, right, midpoint, trapezoidal approximations. All right, cool kids, hold on. We have some more questions though. That was number 33. What's next? Number 47. Yeah, it's on the video, but it's leaving in about 2 seconds. Yeah. All right, number 47. What are they asking for? 47 and 49. 47 says find the average value. That's not bad. What's the average value formula? Good. 1 over b minus a times the definite integral from a to b of f dx. All right, so what do I have at number 47? Who's my b? Who's my a? B. A is 4. So far, so good? And my function is? If you have to solve for average value, if I were you, I'd rewrite this to be x to the negative 1/2 dx times 1/5. Okay, average value, average value. How do I take the antiderivative? Power rule. So plus 2 over 2 would be positive 1/2, right? Divided by m plus 1 divided by positive 1/2. Wouldn't that be multiplying by the reciprocal? And we do have to do some FTC, plugging in bounds and multiplying by 1/5. But my question to you is the following. Tomorrow, when you're solving antiderivatives, what can you always do to check? Derive it. What happens if you bring down your 1/2? What's the new power become when you subtract 1 or subtract 2 over 2? Does it work? You can always double check, yeah? Do you love yourself? You going to rewrite it? I would rewrite it. It's better on my. Now what? How do I evaluate? Fundamental theorem of calculus. F of b minus f of a. So what's first? 9. Just 9? Don't you mean 2 square root of 9? Minus? 2 square root of 4? Go team. So 2 times 3 is 6, and 6 minus 2 times 2 is 4. I'd have 6, 5. If it's a long answer, wait, couldn't I have just boxed it? But now I have 6 minus 2, no, 6 minus 4 is 2. 2 fifths. Anybody get there before me? It's 2 fifths. But my problem's not done, because did anyone read the directions carefully? Part 1 said find the average value of the function over the given interval. But it also says, and all values for which the function equals the average value. The function equals, am I supposed to be finding my, why did I put C if it's X? Why am I putting C instead? What theorem? MVT. Now they didn't say MVT. On the test, I would say MVT, and you would need to know the formula. But they were explaining MVT to you, telling you to find the 1 over b minus a, the integral from a to b of f of x dx. But then later they tell you set it equal to the function. And I could have just done f of x. It's not a problem. Solve for x. But usually they say find the particular values of c. Who is f of c? 1 over the square root of. That's your function. Do you think 2 fifths would be an answer in a multiple choice question tomorrow? Oh, it could be, but would it be right? Because to find the C, the special C, or to solve MVT, you have to keep going. Why am I making such a big deal about this? Tomorrow, I bet at least a third of the Calc kids between period 1 and period 6 will mess up a problem just like this, or at least very similar to. Hopefully. Hopefully my percentage will be wrong and there's like a 90%, 10%, or maybe 100% get it right and 0% get it wrong. We have our average value. 2/5, got it. Now what? Okay, I'm only worried about a few of your algebraic skills, but I am a little worried. In period 1, I said, how about cross multiply? And they were like, okay, never mind. How would you solve it? That's good. A few of you guys did this. Let me just show there is another way, because you're just now. Couldn't you do 1 equals 2/5 root c? Or worse, and you don't remember what cross multiply is? How do you get rid of him? Multiply by the reciprocal. I'll take it. 5 halves equals root c. How do I get rid of root c? Whoop! Right? You guys scare me sometimes. C is equal to 25/4. Only box it if it's in the interval. 6 1/4. Is it inside? Yeah, it is. Dun, 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 dun. Only box it if it's inside the interval. If you find more than one answer and one's outside, don't you dare put that. Number 49. What's the what? Then none. Then none. Number 49. It is a fundamental theorem of calculus part 2. Did I say something about fundamental theorem of calculus part 2 for tomorrow? Okay. What if they give you the function, in this case, f of x is equal to the definite integral from 0 to x of t's. I don't know what t's. T squared times the square root of 1 plus t dt. And they say find the derivative, aka what on earth is f prime? What I do to one side, I do to the FTC part 2. Says what to do when you're taking the derivative of an integral. Do I have an a to x? Yep. Could I call it an a to u? Yep. What does FTC part 2 say to do when I have a to u? Which also works for a to x. I plug it in. So instead of t squared times the square root of 1 plus t, instead of f of t, it's going to be f of u. So I plug in the x, and I plug in the x, and then I do times u prime. But what's u's prime? Just 1. So what would be different if they said something like find f prime of, we'll say find g prime of x. And let's say g was equal to the integral from 7 to 2x plus 1 t squared square root of 1 plus t dt. How would this be different? Plug what in? I have to plug in 2x plus 1 to both of these spots, right? So it would be 2x plus 1, quantity squared, times the square root of 1 plus 2x plus 1. But what would be at the very end? U prime. As long as it's from any a to u, I just plug in my u and then u prime at the end. Plug in my u, even if it's just an x, u prime at the end will always work. Are you sure you don't want to ask me any other questions? You're all right? What was the other question that period 1 was asking? Number 9. 10? You guys were good on number 9? Yeah. Okay. Did you guys see the wording in number 9 where it said solve the differential equation and the initial condition? What was the clue I gave you in the test review that used the word initial, or for the test tomorrow, initial? Although you could have initial position, but what was the clue I said for the test tomorrow? Initial. Oh, did we not write it down? I said it. Initial value problem. Ooh, wait, initial value. If they give you a clue, what do? Anti-derive and plug in your clue to find the plus c. Is there anything, really quickly, I might not be able to do it, but I can answer it, that you guys are confused about on the practice test? Number which one? If f is the antiderivative of such that f of 1 is equal to, this one is a calculator problem. This one is a calculator problem, which would not be on your multiple choice tomorrow. But I'll show you this much. If this is the antiderivative, it's like this should be inside an integral. And it should. They showed me bounds. So I'm going to put a 1, I'm going to put a 4. And they said to call the antiderivative little f. Guess what? Calculator can find you that. They gave me this. All I need to do is solve for him by adding 0 to what the calculator gives me. Bye, guys. See you later. So that was a calculator problem. You can't solve that integral by hand right now.